Next, irrational numbers. We know what are irrational numbers. A number which can be written in p by q form where p and q are integers and q not equal to 0 is known as rational number. So in simple words we can say that irrational numbers are those numbers which cannot be written in p by q form where p and q are integers and q not equal to 0. So example for irrational numbers are root 2, root 3, root 5, pi, etc. We will go to these irrational numbers in details. Then next is real numbers. A collection of all rational and irrational numbers is known as real number. So real number consists of both the rational numbers and irrational numbers. So a combination of both rational and irrational numbers is known as the real number. Next, exercise 1.2 of the textbook. First question, to check whether the given statement is correct or not. First one is, every irrational number is a real number. Every irrational number is a real number. So irrational numbers are numbers which cannot be written in p by q form. We have already stated real number is a combination of rational number and irrational numbers. So every irrational number is a real number. So all irrational numbers are a part of the real number system. So every irrational number is a real number. It is a correct statement because the real numbers consist of both the rational numbers and irrational numbers. So we can say that all irrational numbers are real numbers. Next question is, every point on the number line is in the form root m where m is a natural number. Every point on the number line, we know the number line 0, 1, 2, etc. The positive side, the negative side, -1, -2, etc. So every point on the number line, this is the number line, and every point in the number line is in the form of root m, where m is a natural number. We can say that 1, 2. We can root 1 is equal to root 1, then 2 can be written as root 4, then 3 can be written as root 9, etc. But the negative numbers, here we know that no negative number can be the square root of any natural number. So we cannot say that in the negative side they are in the form root m. So the answer is false because no negative number can be the square root of any natural number. Okay, the next question is, every real number is an irrational number. Every real number is an irrational number. We know that real numbers consist of rational and irrational numbers. So we cannot say that all the real numbers are irrational numbers. It can be rational numbers also. So every real number is an irrational number is a false statement, because real numbers can be either rational or irrational numbers. Next question, are the square root of all positive integers irrational? If not, give an example of the square root of a number that is rational. Are the square root of all positive integers irrational? Square root of all positive integers, We know that we in the example for irrational numbers we have already said root 2, root 3, etc. are irrational numbers. So some are irrational numbers. The square root of some positive integers are irrational, but we know that the square root of 4 is equal to root of 4 is equal to 2. Then root of 16 is equal to 4. So we cannot say that the root or the square root of all positive integers are irrational. Some are rational numbers. So the answer is, if not, give an example of the square root of a number that is rational. So we can say that the answer for all the square root of all the positive integers are irrational is false, because for example root 4 is equal to 2, which is a rational number. 2 can be written as 2 by 1. So this is a rational number. So we can say that the square root of all positive integers is not irrational.